Hey guys, and welcome back to another one of these SUVAT questions. So this, in my opinion, really builds up to some of the more tricky SUVAT questions. So we've done some tricky ones. This may be one of the hardest ones I've seen. Not because of the maths, but again because of the actual understanding of the question, the application of the question. I mean, as you can see, I'm probably looking at part C and D. Looks very scary. The first two parts I would imagine are very easy, but this third part here, part C, that's where people get really confused, really worked up, and it gets quite tricky. So let's go through exactly what we need to do here. So, whilst looking over the edge of a vertical cliff, 122.5 meters in height, Jim dislodges a stone. The stone falls freely from the rest towards the sea below. And again, you can see from the wording, it's very weird, like dislodges a stone. It's very strange. What they're basically saying is a stone drops from the cliff. Okay, so I know with some of these the words they use, it can be very, very tricky, especially if English isn't your first language. But even if it is, I've seen teachers or people get confused by the wording they use. So the only way to really get good at that is to practice a hell of a lot. But if you look at the situation, once again, we're going to draw a diagram as I keep banging on about. We have a cliff like this, and that's 122.5 meters high. Its initial velocity is, of course, going to be 0, isn't it? Because it gets dislodged. Now, you might be right in saying it would have some initial speed, but again, we're not taking that into consideration, okay? The idea is it always starts at rest, okay? Because it falls freely, it's just been dropped. Calculate the time it takes. Okay, cool. So we have S equals 122.5. Again, I don't expect this to be too tricky for you guys, especially if you're looking at a mastery course in SUVAT. These first two parts are fairly self-explanatory, right? But wait for part C, it gets kind of crazy. So if you want, you can skip ahead. Calculate the time it takes for the stone to reach the sea. Well, that's going to be the S equals UT plus half AT squared. This is just kind of standard operating procedure for now. Half AT squared. That first term is 0 because, again, we're dropping it. So it starts at 0 velocity. Rearrange for time, and we have the square root of 2S over A. Okay, and let's put that into our calculator. Where is my calculator? Here it is. So square root 2 times 122.5 over 9.81 gives us all a value of, let's say, okay, 5.00 seconds to 3 SF. Okay. So there you go, 3 marks straight away. Come on, it's so good. Okay. Part B, find the speed. Well, I like to use V equals U plus AT because, again, U is 0. So we're literally just doing 5 times 9.81. I'm just going to do answer times it, and then we're going to round again. It won't really make any difference at all. 49.0 meters per second. It's very, very quick. Incredibly quick, in fact. So, here we go. That's all done. We've got 5 marks so far. And part C, in and of itself, gives us 5 marks. So, 2 seconds after the stone begins to fall, Jim throws a tennis ball downwards at the stone. So he throws it. Okay? Now, that implies there is going to be some initial velocity. Okay? So, if we were to draw another situation out, we have, the cliff doesn't change height, obviously. But now we have a tennis ball. Let's make a tennis ball a little bit bigger, which has a speed of U. And somewhere down here is our stone, right? And I don't know how quickly it's falling, to be quite frank. But I know the difference between these two times is 2 seconds, okay? And again, we're of course going to have acceleration being downwards as 9.81. That doesn't change. And it's 2 seconds after the stone begins to fall, so we've kind of written that in there. Now, interestingly, this tennis ball's initial speed is U, and it hits the stone before they both reach the water. Find the minimum value of U. So, here's where things can get a bit interesting. So, if it hits the stone before they reach the water, then the maximum time that this could take, so for the tennis ball to hit the stone, the max time, so call it T-max, is 5 seconds, right? Because remember, from part A, it takes 5 seconds for the stone to hit the water. So, sometime before that 5 seconds, the tennis ball has to hit the stone. Does that make sense? Now, because it's 2 seconds after the fact, then the actual t max we're going to use, the actual value of t that we're going to use is 3 seconds because it's 5 minus 2. I hope that makes sense. So again, that's why it says find the minimum value of u, because the absolute longest it could take is 5 seconds. So the idea that the tennis ball hits the stone and the water at pretty much the same time, like a fraction of a second right before. So because the tennis ball gets thrown down 2 seconds after, then it only has 3 seconds to cover that different distance. So again, can you see the longest possible time is when they both hit each other right before they hit the water. So they would have travelled 122.5 metres. So here I'm already coming up with some equation, because the max distance they could have covered is 122.5 metres. U is U, because we don't know it. V is, don't really know. A is 9.81. And again, the longest possible time it could take to cover the distance from here all the way down to the water is 3 seconds. Hopefully that makes sense. The equation is probably going to be, yep, S equals ut plus half at squared. Plug in the numbers, or should we rearrange? Let's just plug in the numbers. 122.5 equals u times 3, so 3u. Half of 9.81 is... Okay, no, I'm going to do that on calculator. No need to be arrogant, right? 0.5 multiplied by 9.81. Whoops, God, I can't hit things right. 3 squared. 44.145. I'm not going to round yet because, again, it's not a good idea. God, I can't read either, can I? Jeez. 145. So U is just going to equal 122.5 subtract 44.145 all over 3. And this is the slowest it could be moving. Because if he throws it harder, as in it moves quicker, then it would hit the stone before it hits the water, so somewhere up here perhaps. And the faster he throws it, the sooner it will collide. So let's do that. So we're going to do 122.5 subtract 44.145. 5, there we are. And then we're going to divide by 3, and we're going to round to 3SF. 26.1 meters per second to 3SF. And that right there is 5 bloody marks. Just for that. Now why? Simple. Because you get marks for deducing things like the highest speed, the max time it could take is 5 seconds, which means the max time we're going to use is 3 seconds because it's 2 seconds after. You get marks for all of these individual bits. So it's really, really good, but it is quite tricky. But this is what I'm talking about in terms of SUVAT. If you need to be comfortable with answering something like that, because that can and will come up, but also it shows actual understanding of what you're doing. Doing stuff like this, because this question comes up all the time and it's in all your textbooks and it's in everything, that you can know without knowing how to do SUVAT really. You're just memorizing a formula, you're memorizing a method. Whereas something like this requires actual understanding of what SUVAT is and what's happening in the situation. This is actual applied maths. Because again, in real life, when you do apply maths to real life situations, depending on what degree you want to do, you're not going to have set situations. If you're an engineer, you're designing new stuff, which means it's going to be a new situation. Things like that. So again, this part C, this is the whole point of this A-Level Mastery series, is to explain, if you can answer that, if you can follow these steps, it means you have mastered SUVAT. You can apply it to situations that are different. That's how you get the top into the top 10%. That's how you get the A-star grade, is to understand, because they will put you in a situation that you're not familiar with. Anyways, part D, let's have a look at this, and I'd say this is a bit more of a physics question, but let's think about it. If you had taken air resistance into account, what effect would this have had on your answer to part C? Well, if we think about it, if we have a air resistance, it would slow down the tennis ball as it falls, because the tennis ball is likely larger than the stone, and also it's moving quicker. So that means it has more air resistance. So, first of all, we need to state the actual effect. U has to be larger. U would be larger. Why? Because air resistance will be slowing it down. Because air resistance would slow down the tennis ball. But then why would it slow it down more than the stone? Well, the tennis ball, so because the tennis ball is moving faster than the stone. That's it. So again, we've stated the effect, 1 mark. Then we've explained it. Now I know I like to bullet point my answers because you get a mark per bullet point, but in this case, you need to think about, I'm not going to lie, you could definitely just do this. As in, it would slow down more because it's moving faster. I added this line mostly to explain to you guys. Because air resistance would affect the stone and the tennis ball, so why would it affect the tennis ball more? Because it's moving faster. I can't compare the sizes. The stone could be as big as a tennis ball. It could be bigger than a tennis ball. It could be smaller. Hopefully that all makes sense, and hopefully that was an interesting situation to put you in. But that's the kind of things you need to really think about. If you want more of this type of question, I would recommend looking at M1 papers, which is old spec, but they had SUVAT in it, because there was a lot of this. If you can get hands on the old M1 textbook, which I will see if I can put in the description for you, they have some juicy questions. The M1 textbook was crazy. But either ways, I'll leave you with that for now. But this is, again, the kind of stuff you need to be doing to get those A stars in mechanics.